Welcome viewers and students. In these sessions we have to go see about hyperbola. In previous we learned about ellipse as well as parabola. In the sessions hyperbola. Hyperbola as usual in the section of cone we brought it that path, that is when the cutting plane makes a smaller angle with the axis than that of angle made by the generator of the cone. The section obtained is a hyperbola. In this image here we are able to see the animations how we are get hyperbola curves. While you cut this cone in smaller angle about the generators and axis, then it will shows the cutting section path as hyperbola. So, the various terminology involved in this. Before going to that terminology, we are looking about methods. There are only two methods in this we are following. One is eccentricity method, another one intersecting arc or arc of circles or fuzzy methods. So, only two methods we are following to construct hyperbola. So, eccentricity method. So, what we learned in previous sessions to construct ellipse as well as parabola. The same methods we are following in this to construct hyperbola. This is intersecting methods, but similar way, but the way of technique to construct is different, but the final output as hyperbola. Then terminology. So, we already learned the various terminology in ellipse as well as in parabola. The same thing, focus, directrix, vertex, then eccentricity. And especially in eccentricity we are looking about the distance of focal length to the distance of focal length and a trace point, that line by the trace point and directrix distance, that is perpendicular. So, that ratio is called as eccentricity. If it is greater than 1, then we straight away named as whatever the curves if you obtain by this eccentricity methods, that is called as hyperbola. So, then transverse axis. So, the distance between the two vertex, that is hyperbola having branch off curves, that is two curves, left side and right sides, but we are able to produce any one side, that is enough. But in say for example parabola, so only one part of curves is to be construct, but we are not going for branch off. Similarly for ellipse, so ellipse is a closed curves, parabola and hyperbola open curve, but ellipse also one curve that should be in closed form, parabola one curve that is open, but in open curve hyperbola we are having branch up and number of terms and other parameters involved here is more, because if you draw any asymptotes from the center point, but the hyperbola curve never touch, that should indicate infinity. Mostly this type of structure of surface used in aerodynamics, because whenever flights move in very faster and air restrictions at very high, because we know that Mach number, that is sound velocity, is greater than our sound velocity is lesser, okay. The traveling distance, that is moving speed, is greater than sound velocity, then it's a very high restriction force are applied. So, the nature of surface should be developed to follow the smoothness, that is by use of hyperbola surface. So, it is very important while constructing any high speed vehicles like in aeronauticals. Ordinate, it is similar to what I said in previous sessions in parabola. Ordinate in one half of the vertical, that is y axis distance, double ordinate on both side of the curve. In abscissa, again it is from the vertex to up to the open end, that is called as abscissa. And conjugate axis, yeah, here the conjugate axis tells about a perpendicular line that to transverse axis and is passing through the center of the transverse axis, because we are having the transverse axis between the two vertex, because it's a branch of curve. Two vertex, yeah, here in picture try to see there is a vertex A and B. So the A and B is called as a transverse axis. So in midpoint or center, yeah, from the center if you draw any vertical line, that line is called conjugate axis. Yeah, asymptotes, yeah, if you draw any lines, that lines if you draw a vertical lines from vertex on both sides, so it passing through center points, so but it never touch curve, so that is called asymptotes. Yeah, now we are going to construct a hyperbola. So how it to be able, for that we are taking some problems. Yeah, this is the problems. Now we are considered to construct hyperbola curves. Yeah, the focus and corresponding vertex of a hyperbola are 60 mm and 20 mm distance from the directrix. So actually what it is given here, the focus, try to see the focus and the corresponding vertex of the hyperbola are 60 mm and 20 mm distance from the directrix. Yeah, we have to go through this problem first. Then what they are asking here, draw the conic and from a point of 50 mm from the focus. Yeah, here we have to change. Yeah, instead of 50 mm, yeah, we have to change over to 80 mm. Draw tangent and normal to it. Yeah, this is the problems. So by using this data, how to construct hyperbola. So that is logic we have to do now. Yeah, yeah. Before going to, I want to tell about, yeah, if you take any some basic concept, because that is terminology what we call as, okay. Yeah, if you consider there is a axis, okay, there is a axis. I just axis AB. So in this axis AB we have to draw a vertical line, that is directrix. Yeah. So this is axis AB, this is directrix DD dash. But what about the logic of ellipse? Yeah, in ellipse, if you consider for ellipse, so eccentricity less than 1. So what it mean? Yeah, this is eccentricity less than 1. Eccentricity for ellipse eccentricity less than 1. Yeah, what it actually the statements to give here. So the locus point, yeah, in previous said about k point for locus, but here I consider capital P. So capital P and F, the distance between locus point and focal point, that distance by locus point and directrix. So I just named as D, directrix. The perpendicular distance, yeah, this is perpendicular, but the distance between locus point and the focal point not perpendicular, but PD, that is the distance between the locus point and up to the directrix. So just I do it to some curve. This is we are consider as ellipse, sorry, hyperbola. Okay, yeah. In this, if you trace any points, capital P. So here focus. So this is the distance. This is the distance what we are stated here. PF. Then perpendicular distance from this up to directrix. Yeah, here I named as D, directrix perpendicular distance. That's I named here perpendicular distance PD. That is the ratio. For ellipse it less than. For parabola it is equal to. For parabola equal to 1. That is both distance, this PF, both distance PF and this, so PD, that is equal in distance. So that is parabola. While we talk about now hyperbola, that is E greater than 1, that is PF is greater than this PD, PF. While you tracking this, if you move this point here, at this point, so this P is equal to V at this locations. We are consider vertex point, that is equal to the locus point. So now we termed this distance, by that only we have to construct whether it is a parabola or hyperbola or ellipse. By that only we have to consider. So what about actually here, the distance PF, when it is greater than, if it is greater than, this distance is more, if this distance is more than this, then it is called hyperbola. So by this way only we have to take it. But what here in this problem noted, this 60 mm, what about the 60 mm focus, where the 60 mm focus, so from this, from directrix it's given as 60 mm, so this 60 mm is noted, is it, the 60 mm is from the directrix to focal point. So what about another one, 20 mm, so 20 mm, what about vertex, that is also from the directrix. So this is 20 mm, this is the vertex, 20 mm. Try to see, if you subtract, so what about, it is the total distance, this is the total distance from here, that is from A to F is given as 60 mm, then A to V is given 20 mm, A to V is given 20 mm. So what about FV, that is the question marks, FV, here AF is nothing but AV plus FV, so that is AF. So we know that AF equal to 60 mm, so AV also 20 mm, then from this we have to find out FV. What about FV? So that is, this is the distance V. Here I noted, is it vertex point, that is given in this. From this we have to find out FV. What about FV? Therefore FV is equal to, so 60 minus 20, so 40, so 40 mm, that we have to consider. Okay, first we have to obtain, so what about the distance between AV and FV or VF, whatever it to be, because we have to consider 2 points, that is the concern here. So that is stated to construct hyperbola. But remaining steps, whatever I taught in previous, same for eccentricity method. For eccentricity methods, so for ellipse, parabola, hyperbola, similar. So only condition for ellipse, you have to check the distance between F to another vertex point of ellipse, that is equal to, if you find the intersect point, if you draw a 45-degree line from the focal length that intersect the line AE extended, so from that you have to draw a perpendicular line, it will intersect the axis. So then you measure the intersect point of axis and the intersect point of AE extended, then that is equal to F and V2. So only to check the condition to the other vertex of ellipse, but remaining two, that is parabola as well as hyperbola, no need to checking the conditions, because open curve, for open curve no need to check the other vertex. So that's why it's very simple, but it is also easy. So now we are move on to the drawing board. Here So before starting any draft, that is construction of any curves or any projections, so in this borderline you have to construct a borderline, but to simplify the details, because you are all young engineer, young technical peoples, so there are a lot of layouts are there, but simplification we are given here. Yeah, above that you have to do a guideline for detailing about dimensions, so whether it is a millimeter or centimeter or meter, but we are not using meter because we are using centimeter, but probably we are using only millimeter in this drawing sheet. Yeah, hyperbola. Yeah, the title is hyperbola curves. Yeah, here we have to construct a hyperbola. What we are seen in these problems. This is the problems. For these problems, we have to construct a hyperbola. Yeah. So take the scales. Yeah, draw any length of line, that is axis line. Draw any length of axis line. So line AB. Any length of line AB. Then draw a directrix. Then draw a directrix. Then draw a directrix that is perpendicular to line AB. D dash directrix. So next step we have to mark focal length. So what about the distance between the focal length and directrix? It's given, that is 60 mm. By using this scale, so we have to construct, that is mark. So we have to mark. So 60 mm, that is 6 centimeters here. Yeah, 6 centimeters mark. So this is F. F focal point. So 20 mm. So what about the 20 mm? Yeah, again we have to measure 20 mm. Yeah, 20 mm. So we have to mark 20 mm. That is vertex point. That is vertex point. Yeah, V. That is vertex point V. So next step we have to draw a vertical line from vertex. That is vertex point V. So from this point we have to draw a vertical line. Then take compass, measure VF as radius, measure, take compass, measure, measure VF as radius, VF as radius, V as center, V as center, make an arc to intersect vertical line, make an arc to intersect the vertical line from point V. So that is the logics. Yeah, here. So how to do it? That one. Here, take it compass. Yeah, from point V, measure from point V, measure the distance. Yeah, this is the problems. Yeah, actually it not comes. So we have to turn. Yeah. The same distance, otherwise you have to take and mark it over the vertical line. Yeah, using scales. Yeah, by using scales, the same distance. How much distance? Yeah, already we have measured. The distance between VF is 40 mm. So 4 centimeters we have to mark. Yeah, we have to mark here. Yeah, this point. Mark that point. This, that is 40 mm. So after marking, that is E. We are named as E. That lettering point is E. You now take scale. Now take scale. Now take scale. Keeping this A as A and E extended. E. E. Yeah, here this is pivotal point here. So we have to rotate E. And now draw a line AE extended. So we have to extend. We have to extend AE extended line. So after drawn AE extend, so equal or unequal, that may be, but probably don't no need. Okay, no need to equal distance. So roughly we have to construct a unequal distance, yeah, within this line. So otherwise it's very difficult to construct curves out of this. So within this we have to make a points. So here 1, here then 2, 3 and 4. Yeah, this is enough. So 1, this is 2, this is F, 3 and 4. So 4 point we are taken to construct this hyperbola. So now draw a vertical line. Now draw a vertical line. Yeah, here I am not using mini drafter, but in actual practice please handle mini drafter. So in mini drafter we are having two scales perpendicular, mutually perpendicular to each other. So once if you put one scale is parallel to any one of the line, the other scale is perpendicular. So by that way only you have to draw a perpendicular line and parallel line. But actually in this software I am not available that. That's why I am using scale for all types of constructions. Yeah. So now draw a vertical line. Now draw a vertical line. To intersect AE extended. To intersect AE extended. Then from line, then from point 2. Then from point 2. Then from F, also consider F. Then point 3. Yeah, then point 4. But here what we need to do, only one side we are doing, is it? But actually on both sides. So try to apply on both sides. Apply on both sides. It again similar, okay, whatever we did it already in previous session, same thing here we have to follow. Yeah. And now we are drawn the line passing through point 1, 2, 3, 4 and also F. So then lettering. So now we have to choose lettering to each intersect points of AE extended. This is 1 dash. AE extended, the vertical line passing through 1 is 1 dash. The vertical line passing through 2, 2 dash. The vertical line passing through F, F dash. The vertical line passing through 3, 3 dash. The vertical line passing through 4, here 4 dash. So we have to mark 1 dash, 2 dash, 3 dash, 4 dash and also F dash. So then we have to take compass. So then take compass and measure the distance. Measure the distance from 1. Measure the distance 1. 1 dash as radius. 1 dash as radius. Measure the distance. Try to see here. Measure the distance. Measure the distance. 1 dash as radius. Yep. And now measure 1 dash as radius, F as center, F as center. So make an arc to intersect. So which one it to be intersect? Where you measure that line. So that line to be intersect. So intersect the line from vertical. Okay, intersect the vertical line from point 1. So that line you have to intersect. So now we are measured. Measured 1 dash as radius. Now we are measured 1 dash as radius. So that by keeping this FS center, make an arc to intersect. Yeah, make an arc to intersect. Just a moment, I come back. Yeah, make an arc to intersect. Here, make an arc to intersect a line from 1. So, yeah. Yeah, make an arc to intersect a line from 1. Similarly, in above, that is above and below, both sides you have to make an arc to intersect above. So intersect and give a lettering. This is P1 dash. Yeah, this is P. This point is P. Okay, because it disturbs the curve, that's why I am put it in away from P. So P1, that is P suffix 1, that is P1 dash. In similarly, measure 2 dash as radius. In similar fashions, so now we have 2 dash as radius, FS center, make an arc to intersect the vertical line from point 2. So now we have to take this campus, so measure that is 2 dash as radius, measure 2 dash as radius, FS center, make an arc. So make an arc, FS center, make an arc to find above and below, make an arc to intersect a line from 2. Make an arc to intersect a line from 2. Then lettering P2 dash, this is P2 dash. Don't mind think AE as asymptotes. It's not asymptotes. It is used to construct hyperbola. But it's not asymptotes. Asymptotes is different, because already I said asymptotes never touch the curves. But while you thinking here, there is a line. Oh, it is asymptotes. So why it to be touch the line? That is the touch the hyperbola. But it is not asymptotes. AE extended line is not asymptotes. It is used to construct hyperbola. For that method, we are using this line. Okay. So try to remember. So sometimes you are assume, yeah, this is to be asymptotes. It is not asymptotes. AE extended line is a construction line to construct hyperbola. Yeah, similarly we have to take this campus, measure, yeah, the distance is same. Okay, there is no need to take f dash as radius, no need of. Now we go for next points. So 3 dash as radius, fs center, 3 dash as radius, fs center, make an arc to intersect the vertical line from 3. From point 3. So that line we have to intersect now. Here. In this, now we have to measure 3 dash as radius. Measure 3 dash as radius. Measure 3 dash as radius, fs center. So now measure radius, then change the positions. Now fs center. Now fs center. Make an arc. Fs center. Make an arc. So above and below. Above and below. Above and below. Make an arc to intersect above and below. So now lettering. So this is P3 dash, this is P3. In similar fashion, so what about the distance between? Here we have to measure, because bottom no problem, there is a external line and measured points of f dash, but in above there is no. So we have to measure that is also. So measure f, f dash as radius. Again it to be intersect the above line. Now it to be marked p suffix f dash. Here you have to put a pf. That's the last points 4 dash. You have to measure 4 dash as radius. 4 dash as radius. 4 dash as radius. 4 dash as radius. Fs center. Fs center. Fs center. Make an arc. Make an arc to intersect. Make an arc to intersect. Below and above. Try to see. It is out of. It's out of. Is it? That's why we have to limit it for hyperbola. If you give so many, it will be out of paper. So we have to limit it. So this we have to consider arc, but there is no vertical line, is it? So we have to extend and find out the points. Extend. Only one point, is it? So no problem. Now it lettering. This is P4 dash. Here P4. So after finding number of points, locus points, number of locus points, then by using 2H pencil. By using 2H pencil, draw a smooth curves by line joining of by free hands, but from V P1 we have to draw. From V we have to draw smooth curves. Yeah, similarly in bottom we have to draw a smooth curve. Yeah, this is F. It's along that. Yeah, smooth curve along that intersect points. So up to this we have completed by use of 2H pencil. By use of 2H pencil, please construct all. Already I said, while you go for any construction, initially use 2H pencil. Then only you have to trace after produce, after get a proper curve, then you go for trace. So for using of H pencil, here I differentiate colors. So red colors, that is H pencil, and also thicker. So I just thick and continues to draw the line to trace over what I did in 2H pencil, that is hyperbola. Hyperbola. Yeah, this line is called hyperbola. Yeah, what about this problem is not over, because only we are constructed hyperbola, that is drawn. As per these problems, we are drawn. We are drawn this, draw the conic, and what about from a point of 50 mm? Here it's given 50 mm. So instead of 50 mm, we take 80 mm. Okay, because the campus, what we seen is it 5.3 centimeter. So you have to take 80. Then draw a normal, that is tangent and normal. So from the focus point you have to measure 80 mm and make an intersect either below or above. So from that point you have to construct a tangent and normals. Yeah, that we have to do it now. Yeah, now we have to mark that. Yeah, for that we have to measure it on the scales. Yeah, using this. Yeah, you have to take in the scales 0. So now we are measures 8, that is 80 mm, 8 centimeters. So measure 80 mm. Measure 80 mm. Measure 80 mm. So this you have to bring it there. So F is center, because from the focus only it is given in the problem 80 mm, from the focus only 80 mm. So then we have to construct a, it to be intersect, it to be intersect. So it is intersect, that is capital P, point P. This point is termed as capital P, this point. Okay. So now draw a line. Now draw a line. I just change the color by using the scales. Okay, I shift by placing this. So draw a line. Draw a line. So next step we have to draw tangent. So how to draw a tangent? It is a tangent line, it to touch the curves, it not intersect. So for that we have to draw a perpendicular line from point F to the new locus point capital P and F. So for that we have to draw by using mini drafter scale. Yeah, if you are placing mini drafter scale, what I put it this position here, The other scale is perpendicular. Suppose I take another scale here. Yeah, to showing the minute after scales. Yeah, here if you take the other scales, that should be perpendicular. Yeah, here. Yeah, in this other scale is perpendicular. Yeah, it is perpendicular to each other. Is it mini drafter like this? So in this end particular, it to be have some angular dimensions. So by using mini drafter, so you have to set one scale to draw a line capital P, that is newly constructed point P and F. So the other scale is perpendicular. So with the help of that scale, you have to draw a line. Draw a line that intersect the directrix. So that is the tangent point. That is the tangent point. That is the tangent point. So from that point you have to construct a tangent line. Now we have to take the scales and placing over this point. Here, then placing over this capital P. So then draw. Yeah, because directly you have to use H pencil. So by using H pencil, we have to construct this tangent. Again I tell you, after after drawn this tangent, the other scale of mini drafter is perpendicular. By using that scale only, so we have to draw this. Again I bring it the scale to there. This is tangent. So another scale. So we have to draw. Yeah, another scale. Yeah, from this. Another scale is perpendicular by use of mini drafter. So then construct. This is normal. This is normal, this is tangent. So this is the way to construct a hyperbola. Yeah, in this way only we are construct this hyperbola. These are the methods. Yeah, already I said in ellipse, that is closed curve, then parabola, it's open, and now it's a hyperbola. Yeah, by this way only we are construct this one. Yeah, it is one branch of, because there are two set of curves, hyperbola set of curves, but only drawn one side of curves. Yeah, if you want to, yeah, it is on both sides. So with this we are completed the sessions. So by this I conclude. So thank you viewers.